Welcome, everybody. Tonight we're working on Unit 10. The primary topics for tonight are creating databases, creating tables, and creating indexes. And just to start with, right off the top of the bat, we already know what a database is. In principle, we've kind of already played with the create a database command, which is actually pretty simple, but we'll also look at its inverse command, which is to drop a database and how it is very destructive. Also look at tables and how to create and drop those. And then we'll look at what an index is and what its purpose is inside of a database and why it's important and valuable for database creation, manipulation, and storage of information. Um, all right, so I have a listing of the topics here, and I have kind of a pretty verbose list of things that we're going to look at, mostly on W3 schools, which is pretty normal. But I do want to point out the fact that the MySQL tutorial site also has in the same type of information with a slightly different perspective. And what I always tell my students, it's not a bad idea. You're listening to me, or you're reading a book about it, or you're looking at a website about it, to look at a few different sources, because sometimes when things are explained to you, one site will explain one aspect better, or I might explain it better or worse, than another site. And sometimes getting that broad sweeping input gives you a better and firmer understanding of the topics. But I'm just going to kind of rifle through the topics here so you can see some of the things that you can do. Some of this will apply to our homework tonight. Some of it will not, but I think some of it is also very helpful to know. And I will kind of like review all this stuff as we kind of go through the materials, but we're going to hit the W3 content first. And then you can see I have like a significant amount of references here on purpose, because I think this stuff can be a little bit trickier in some ways. And then, as usual, I will try to kind of explain, why I think the stuff is practical to use, or how it works with some practical examples. All right, let's go to W3 schools. And once again, I'm gonna bring up the Brave browser here to do my surfing in this environment, just to kind of block out some of those ads. And so I'm going to be copying some of the links and moving them over to that browser. And maybe one of these days I'll get smart and just log in on Brave. But I'm happy typically with just using Chrome. All right. Let's start by looking at the create database statement. It's really very, very simple. As you can see, you just use the keyword create, the keyword database, and then you give it a name. Now, we see this really weird mix with the databases that we've been using, where some of them have capital letters or lowercase letters. And I will tell you that functionally a lot of that is ignored. Right. That's not true in all database systems, but generally speaking, it is case insensitive, as are the keywords. And you see me very typically, and I think on my part, it's an aspect of laziness, where I don't want to type things in all caps or turn on the caps key and then turn it off. So I usually just keep everything lowercase. That's me, right? Older database fanatics, of course, would yell at that and go, no, your SQL commands have to be all uppercase. That way, they're keywords and they're not database names or column names or, whatever. And people have very strong opinions about it. In the old school world, like the world that I learned how to do this in like decades ago, you had to do the commands uppercase, and it was case sensitive. And I'm not really sure when that altered, or if it was just a design feature of MySQL, but whatever you're comfortable with, basically. But to create a database, it doesn't take much to just create the initial foundation, right? You just issue a command like this, and then all of a sudden you have a database. Of course, it is empty, right? So there's nothing really to look at. There's no tables yet. There's no columns. There's no anything, right? You basically created a shell that will hold everything else. So if you're going to create a table, you have to have a database first. One other kind of interesting command. And this is, kind of an interesting one is this command here called show databases. And I'm going to do kind of like a weird thing here. And I think I might have to get on the VPN to do it. So if you guys don't mind, I'm just going to get myself logged in here. And yeah, I know this is being recorded, but whatever. People can't get in here without an account anyhow. But I am going to type in my ridiculously long password here. And I've gotten to the point where I can talk and type it at the same time. Do it so many times a day. And then I'm going to authenticate myself on the phone here. And this is not unusual when you're accessing what we would call server resources in a remote location. So I'm at home right now teaching this class. Our campus is, 38 miles away or something like that. They don't want me hopping on the network to secure systems basically without doing that VPN connection first. Now that I am on the VPN, you guys might get a little bit of hiccup in my Zoom stream, and it would be like very, very minor. I assure you the recording's just fine. But as I basically shift from being on my own network to, in principle, having a network connection to campus with a campus IP address, that's what the VPN brings you. Now, for anybody in the web program, eventually you will need that VPN connection for certain classes. And we do that on a per class basis per semester. It's not an automatic for students. And we actually have found workarounds for using it in most circumstances with a couple little exceptions. What I'm about to do right now is I'm going to actually hop back over to Chrome for just a second. And I know that we've taken a look at this interface before, which is accessing our Prometheus database, which is the web server for students in our web software developer degree or the web programmer degree. And I can log into the MySQL database on the web server through a web-based piece of software called PHP-MyAdmin. We have talked about this in the past. And when I go into this environment, and I'm just going to go in here and just show you, right? And I happen to be root on the system, so I can see and control and alter and do all sorts of crazy things for all the databases, all the users on the system, right? Including, we've discussed this too, I can run SQL commands right from within this environment, just like I would in MySQL Workbench, and have it affect, all the same things that we've learned how to do in MySQL Workbench, you could in principle do here. Now, prior to this type of software existing, either like a DBMS like MySQL Workbench or a web-based one like PHP-MyAdmin, the way that database admins would typically do database work, and mind you, this is how I learned. And right now, what I'm doing is I'm launching a piece of software called Putty. And this is a piece of freeware you can find out on the internet. But basically what Putty is a terminal program that allows me to establish a command prompt window or a terminal on a remote Linux system from my Windows machine. This only works on our VPN, by the way, so anybody trying it that doesn't have a VPN account won't get in. So I'm going to go ahead and run this, and you can see, and the prompt is pretty small, unfortunately, but I'm going to go ahead and log in as root here. And I think type the right password. Okay, there we are. So now I'm actually logged into the system on a command prompt level. So I've connected to a web server on campus through a Linux command prompt, and now I have a prompt here, where I can type commands. So for example, from a Linux prompt, I can type a command like ls, which is to list the files or folders in my account. And right now I'm in my home account, so I can see that I have a web folder for publishing web information. And if I went in there, for example, I could see all the folders that I have relative to that. Okay. And all right, let's back out of there though. And my real point for doing this is to show you how in the old days we would run MySQL. Um, and I don't know if I should run this on the root level. That's probably not wise. I should probably run one of my sub accounts, and then I'll be prompted for the password. So I don't know if you guys can make this out because this is kind of a small prompt, but basically I'm just typing the command at the prompt that says MySQL -u, which is that the following will be my user account. So CCCCC, that's my C account, is my user account name. And then I have a -p, and then it will prompt me for the password for that account. And so I'm typing that in right now. What's interesting about working from a Linux command prompt, and I am fumbling with what I'm typing here, by the way. Okay, so I mistyped it. Let's try that again. So I'm going to hit my up arrow, and this time I'm not going to talk while I type in my password. Okay, so I'm not typing in the right password, apparently. But my point is, and I'm going to try this one more time because I feel like I owe it to you guys to show you. And let me see if I can try one of my other accounts here. Okay, now I'm in, and what you'll notice, and I don't know if you guys can make this out, this is how it is on the command prompt, but I am now inside of the MySQL program called MySQL Monitor, which is a command line database management system. And now that I have a prompt here, I can type all the database commands that I could type in a query window inside of MySQL Workbench. So for example, I can do a show databases semicolon command, press enter, and this shows me all the databases attributed to my account. And if I wanted to create database, and I'm doing this from the command prompt because I want to show you that it works basically. And I'll call it whatever, but I already have a whatever. So I'm going to call it whatever 2, right? And it's got to be terminated with that semicolon. Just in like regular SQL code, I can go ahead and press enter. And now I'm getting a error message. I'm trying to read what it says. Do I have a whatever 2? Okay, yeah, it's denying me, but the bottom line is I probably need to switch permission so I can add it. I'm not going to go through the trouble of doing that right now, but I could, in any circumstance, run a query, create a database, or any of the work that we do, and I can do it all from the command prompt, right? The interesting thing is there are still a lot of database administrators that prefer to work from the command prompt for a lot of different reasons. You can, in essence, do all the same tasks that you can do within a graphical environment. And in some cases, they just feel more comfortable in this environment for a lot of different reasons, because you're kind of working native on the operating system, basically directly on the machine where the database exists, as opposed to using a piece of software that interfaces with the server. So I'm going to actually exit out of here now, and that's just basically my my little demo, although sort of failed, but whatever. Just to give you that idea that you can do that. Another command that we can do, so here we learned the create database command and the show databases command, because like if you are at a prompt, so why would you need show up databases when I can just look in the left side of MySQL Workbench and see my databases, right? But if you're at a command prompt, that command is actually helpful to show you all the different databases that exist on the system. And you might be surprised how many there are on a database server. It might not just be one, it could be hundreds, you know, and that's the case here for our students. So like all the students get an account and then they end up creating multiple databases for different reasons. The related command to create a database is to drop a database. All right. Very, very simple command. Just drop database instead of create database and then the name of the database. All right. And notice the little yellow box here. Right. If you run this command, your database is gone. There is no undo. Right. You can't go, oops, control Z, you know, or type undo or something like that and get it and bring it back. That is just not going to happen. It is just completely destructive. That database is gone. All its tables, all its data, all the work you put in is gone. So like a command like this on a database system is often locked out for most users of the system, right? What we've been working in the mode that we're working on, we own the database that's running in the background on our system. So when I go into the task manager and I go to services and I find MySQL Workbench or MySQL, this is the server software running on my computer. I have root level access and I'm signed in as the root so I can see all the databases. I can do whatever I want. And so as the root, and you know what, I have MySQL Workbench here. Just go ahead and connect and you can see the root account is right there. I can go in and do anything I want in this environment. Create a database, drop a database. And you know what? Why don't we just practice with that really quick? And I'm just going to close all the query windows that are open. And I'm going to collapse down everything in the schema table. I know what databases I have. And notice I have a whatever and a whatever too. You know, so I guess I'm going to do a whatever 3, but I'm going to create a new query window. I'll zoom in and let's just practice those commands. Let's just type create database, whatever 3. All right, let's execute that. And it worked, right? You can see that at the bottom down here, right? And it says 1 row affected. Now, if I refresh my schema and look, there you'll see whatever 3. If I expand the triangle, it has structures for tables and views and stored procedures and functions, but I have nothing in there, right? Because there's no like expander arrow next to it. All right. To remove the database, I just say drop database, whatever 3, and then I'll run that command. Right. Notice now it's 0 rows affected, and notice it immediately disappeared from the schema table. So if I had like a gazillion records, you know, 50 tables and joins and all this stuff created, I just destroyed all of it with one command, right? So this is why this command should be very, very carefully used. You know, don't just go throwing that one around because it is a highly destructive command and to be avoided. And they do have like, you know, little tips here. Once again, if you are at a command prompt after you drop something, you'd probably run this command just to verify that it's gone. Whereas if I'm working in a graphical environment, I can just see it right away. So that's one advantage of the graphical environment. All right, let's move on with material. So we looked at create and drop database. Now we're going to move on to create table, drop table, and alter table. So let's go over here, and you'll notice here in the database area of W3 schools, those commands, you know, come one right after the other, so it works out really nicely. All right, so the create table statement is used to create a new table. Now we've used this before too, sort of out of necessity, but basically the form of it is you create a table, you give it a name, and then inside parentheses, followed by a semicolon, you indicate the name of the column, which needs to be unique, and its data type. And then we've also learned that you can indicate if it's a primary key, a foreign key, if it needs to be null or whatever. And the designing of the database really should be predetermined. I wouldn't just go into like a database product and go, let's see, I think I'll do first name, last name, address, whatever, um, like I often do, just randomly. That makes no sense, right? If I'm going to create something, I need to think about the design aspects first before I just willy-nilly start building it. There's a couple reasons for that. One is if I go in knowing all my data types, my columns, what needs to be there, then chances are I know how that interfaces with all the other tables, all the other data in my database, and it'll probably work better because I thought about it in advance. It's kind of like having a blueprint for a house rather than just building it with, materials and then going, oops, I guess I should have made it taller, that type of thing. Now, it is possible to change stuff that's already built, but if you build it right the first time, the way the data goes into the database on an electronic level, in other words, how it gets stored in memory and on a hard drive or whatever, will be more sequential and ordered, and therefore your database will work faster. This is kind of a weird little thing, because if I like come up with 3 columns, then go, oh, you know what, I need 3 more, but in the meantime I've done all this other work, the data gets fragmented, right, and can impact performance. They have an example here, so I think what I'm going to do is I'm just going to like borrow their code, if you guys don't mind, and I'm going to do the demo over here in MySQL Workbench, and let's actually blow these commands away, and let's come up with let's call it a new database, something like that. So let's run that command first. All right, so I have a new database. I'm going to refresh and make sure I can see it. There it is. And then inside that, I'm going to use this code I borrowed, right? And go ahead and create it. Now, you guys will notice there's no primary key or not nulls or any of that. That's not the point of this, really. But let's execute that command, and you'll see that that worked. And then if I look at my new database and go to tables, right, let's do a refresh here. You notice how sometimes when you work with this stuff, okay, I think I know what just happened. It's not going where I want. I think I put the database here. How do you like that? So what did I forget to do? Okay, yeah, this is a classic mistake, right? If I had $1, and that's why in my schema table, classic models kept coming up, right? And I don't need the database keyword here. I just need to say use, and I'm going to execute that. All right, and then I'm going to run this query, and you see that worked. And now if I come here and I do it, let's do a refresh on the schema now. You'll see how I got the little expander arrow, and now that table is present. Okay. There's no data in it or anything like that. But you know what? This is going to lead us really nicely, kind of by accident, to basically the next command, which is to drop a database. I'm actually going to attach back to this, or drop a table, excuse me. And what I'm going to do here is I'm now going to use the classic models database, and then I'm going to execute the command to, well, let's go look at it at W3 Schools first before we execute it. The command for dropping a table, which is similar to create. Once again, the command is just drop table and the table name. And in this case, the command is drop table persons. Because I ran the use statement on classic models, you see it right down here. When I execute this, it should remove that table there. So let's run it. You saw it go away, right? And you can just refresh it to make sure, while the one here in new database is still present. So that's another of those commands. This is one of those, once again, usually when you're building a database, you're not like dropping stuff unless you're in the design process and made a mistake, or if you decide this data is no longer needed. But once again, as the yellow warning says, you do this, that stuff is gone. It's not coming back, folks. Right? There's no undo. Right? And they have examples. There's kind of a related statement here. And this one's kind of interesting. So if you have like, yeah, okay, we got this table, there's all this data in here, it's really old, we don't need it anymore. You can run the truncate table command, and that will not destroy the table, but will destroy the data, right? So be careful which of those commands you choose. I could demonstrate this one, but I think that's pretty self-explanatory. Truncate table does not destroy the table. The structure, the holder, or whatever you want to call it, is still there, but the data inside the table is gone. Another really useful command is the alter table command, and we've already played with this one as well. I don't know if you guys remember or not, but basically what we do with this one is we use it to either add a column, remove a column, or change a column in some way. And they have examples of all of them, but the general syntax is you say alter table, the table name, and then you use the add command, the column name, and the data type if you're adding, right? And so they have an example here, if they wanted to add an email column, maybe they built a database before email was a thing, and then they're like, okay, well, we better have an email column. Here's a command they can use to do that. So alter table customers, assuming you have a customers table, add email and its data type and whatever other parameters go with, if it's foreign key or, not null or whatever, that can all be designated and very useful, right? So if you want to like make a table bigger, right? If you want to make a table smaller, in other words, remove a column, you can use the alter table command. Similar syntax, but notice in the second row or line, instead of saying add, like we did here, right? So, and notice here when we do add, it doesn't, we don't need the keyword column, but in the drop command, the column keyword is there. And I think that's kind of a intent, right? They're like, well, we don't just give them drop because then they're going to be deleting stuff and they're not knowing what they're doing. This ensures that, oh yeah, when you drop, you have to say column also, right? I wish they would do that for a database, but I guess whatever. But this removes the information and the data is also gone, right? So you're not retrieving that data. They don't have a yellow box on that one, but that's how it works. There's also the modify column. And you'll notice here that, what this will do is basically change the column to a different format. They have a couple of examples down here. Like if you wanted to change, for example, and you see how they do this, right? So this is adding one, whatever. Changing the data type would use the modify column command, right? And then you would declare the column and what data type you're changing it to. And it could also damage data in the process. So you have to be careful with this one as well if you're doing a modify. If you just straight up drop a column, we already looked at that, and I think those are all the examples here. All right, let's move on, and I'm going to talk about a few of these topics here just to kind of follow the stream, and these are kind of, we'll circle back to indices, right? But we're going to talk about constraints, primary and foreign keys, and then we'll work our way to indexes and auto increment. All right, so back over here in the Brave browser, we'll talk about constraints. All right, and this one's kind of an interesting one because it says SQL constraints are used to specify rules for data in a table. Constraints can be specified when the table is created with the create table command or after with the alter table command. So if you figure out, like you make the table and you're like, oh, I guess I need a constraint, to control it a little bit better, you can do it with the alter command. So, and I don't think that that's as harmful to the data or fragments the data as much as some of the other commands, by the way. The general syntax. And let's talk about why we do this, right? Constraints are used to limit the type of data that can go into a table, and it ensures the accuracy and reliability of the data in the table. If there's a violation between the constraint and the data action, the action is aborted. Constraints can be at the column level or table level, and that's kind of interesting. Column level constraints apply to a column, and table level constraints apply to the whole table. So some of the ones that are commonly used. Now, interestingly, we've already been using some of these, and that's why this is kind of neat. So one constraint I can use is not null, meaning people can't enter data for a record without including it. So for example, your last name in a customer table might not be allowed to be null. You have to have a last name. Another constraint that's kind of interesting is the unique keyword. And I don't know if they like demonstrate all these here, but I think you have to, there you go. So like, for example, an ID might be an integer and it can't be empty, nor can last name or first name. The age could be blank, like a lot of people don't want to provide that, obviously. The unique keyword is a little different. It basically ensures that a value would be unique in the database. So for example, and this is kind of interesting too, right? It ensures that all the values in a column are different. So for example, if I put the unique keyword on last name, that could be a problem because there's probably lots of people with the same last names, right? But on an ID field, that's important. Now, mind you, look at the second sentence here. Both the unique and primary key constraints provide a guarantee for uniqueness. So if I say primary key, unique is already applied. I don't have to say it explicitly. But if I was looking for a different value, for example, if I didn't designate this as a primary key, I could still make it unique by using the unique keyword. And basically you just say unique and then which field it applies to. That's one approach, right? Another approach, and I want you to look at the syntax here, is to say that here, right, this is being declared as a constraint for person, and unique must be a combination of the ID and last name together. That's kind of an interesting thought, right? I've done some databases where I did some stuff like this. I'm not sure it was always the best thing to do. If you're altering a table and you're adding a field, you can do it after the fact, like this, or the other approach that we saw. Right. If you want to remove a constraint, and this is a little bit of a clue as to why we're talking about it, that constraint of forcing something to be unique is in essence an index. So we're dropping an index. We haven't learned about them yet, but we're about to. Okay. I'm going to go back one screen here. We've talked about primary keys and foreign keys, right? And how those work. And I don't think we really need to review those too much. We can also use this constraint, which is to check to see if a value in a table fits a certain thing. So for in other words, if I had a table for persons and then, let's say maybe this is to hire people or something like that, and people have to be 18, I can type in this command here that says check to make sure that the age is greater than or equal to 18 to enforce certain values. You can also write combinations. They have to be greater than 18 and they have to live in a certain city, so you can get kind of creative with this one. You can do that also, by the way, with the alter command as demonstrated here. And I'm not going to demonstrate any of this stuff, not really needed for homework. There's another interesting constraint, which is called default, which is to set a default value for a column. So let's just say, I build a database that's intended for citizens of the city of Milwaukee, right? Not for citizens of the city of Racine. And so when I'm putting a person's name in there, I still want to capture the city because maybe I want to send a mail or something like that. And I would have a default value that's predefined, right? So when I'm defining the column, I define it, and then I have a default value for it specified in advance, assuming everybody's going to be from that town. And I really don't want people from other towns in there. That would make sense. Or even if I do, I might preset it to a certain thing. So for example, if we were doing something about the technical college system in Wisconsin, I would assume that everybody is from the state of Wisconsin. So I might preset the state, right? But as you guys know, we sometimes get students from Illinois that come up here, take our classes. Heck, I've had students from other countries take classes of mine. Actually, I had a 12-year-old kid from India, by the way, that took one of my classes, which is kind of interesting. All right, going back one more here. And then you see the next one, which is create index, which leads us very nicely into the next topic. So the create index statement, in essence, is a type of constraint in a sense, right? Um, an index is kind of an interesting thing. And I'm going to start with a kind of a weird example talking about indexes, because often when we have like a printed book, right? And you're trying to find something in the book and you look in the table of contents and you're like, I'm not finding any information on, I don't know, mountains, right? So you can't find it in the table of contents. So what do? You go to the back of the book, and if you're lucky, the author's created an index so that when every time he talks about mountains, he lists mountains and then where he can find it in the book by page number or whatever. And it's kind of a neat way to be able to find something that otherwise might be difficult to find, right? So what an index kind of does is it gives you quicker access to information because we've taken note of where stuff is. And instead of searching or running a query to find it, you can use the index to speed up that query. And it says right there, indexes are used to retrieve data from a database more quickly than otherwise, right? All right, if we have a small database, not a big deal typically, but if we have a humongous database with tens of thousands or hundreds of or millions of records, having index created really significantly speeds up searching. Now, I'll have you ponder this. When you go to Google and you type in a search term and then press enter to get results, where do the results come from? They come from a database. And when people perform the same searches over and over again, the search results become indexed by Google. In fact, they call it that. And therefore, why does Google give you such quick search results? Because they're already indexed, right? So it can get to it much faster and retrieve the information. I want you to notice the note in yellow, though. Updating a table with indexes takes more time than updating a table without, because the indexes also need to be updated. So if I'm changing a table structure, then the index has to also change to match what's being changed. So only create indexes on columns that will be frequently searched against. Not every column needs to be indexed, is the point. If I'm creating an index, you can see the general form of it here. Is you can use the syntax. And notice, I want you to notice that there's two forms. One is to create an index, which basically takes note of all the information. The index itself gets a name. And if you look at MySQL Workbench, when you look at structures of databases, well, they don't list indices here, but there's an indicator for it. But you see that they have indicators for views, procedures, and functions, by the way. All right, let me just flip back there. And you can also create indexes which are unique. And like, for example, a primary key is unique. Or if I had a column in my database for, let's say, social security number, that'd be a great example. I wouldn't necessarily make that my primary key, but I would want that to be unique because nobody has the same social security number here in the United States. All right. So to create an index, you just say create index, and then you indicate the table. So IDX last, or okay, you indicate the name of the index you're creating. I apologize, not the table. So, and I want you to notice that there's a convention here that programmers will often use a prefix. You do not need to do this. It is not required that you give it a prefix, but for whatever reason, database people have kind of come up with these standards. This is not how I would indicate indexes when I would do them. I would just say index underscore last name. That's what I would do personally. And different admins will have different approaches, but some sort of thing. It's pretty quick and easy to figure out just by looking at the prefix. Oh, that's an index. That's the point of it, right? So name it, and then name it along with which column it's affecting. So it just makes sense. Persons is the table, last name is the column being affected, right? And then I'm naming the index to match the column name so I know what I'm indexing, right? So that just makes it a little bit clearer when you look at it later. Here's another example where we're creating an index for, well, it says P name. And what you'll notice is that still in the same table, but now I'm taking two names together. So I'm taking the last and the first name and creating an index for their combination. Now, this is something I've done in databases often. So that way, if I'm looking up the first or last name, it finds it, right? See the cleverness of that? You can create an index as well, but you can also remove one. To remove it, look at the difference though. You're not creating, you're altering your table and you're dropping the index and you give it the index name. And that just removes the index if you don't need it or you find it slowing your database down or whatever, right? As the suggestion indicated, you don't want to over-index your tables. You want to index the stuff that's likely to be looked for because that speeds up search results. All right. I'll move on to this other topic here, which is auto increment. And auto increment is a really useful feature. It says it allows a unique number to be generated automatically when a new record is inserted into a table. This is often the ID field for the table and often the primary key as well. So for example, I might say every time I add a new record, I would auto increment the primary key. So the first user is user one, the next user is user two, and so on, right? It just automatically increments. I don't need to enter it. It will auto increment. However, you can define some of that stuff, but just for example, if I was creating a persons table, right, and I have a person ID that's an integer. Now, be mindful of this, right? You can create an ID that's text, you can, right? But if you're going to increment it, it makes sense for it to be a number and it makes sense for it to be an integer, correct? Correct, yes. All right, so the person ID will be an integer, it can't be empty, and it will auto increment. So that means I don't need to set it, the system will set it automatically. Notice that the primary key indicator is put down here. You could also add that up here, but either way, it works, right? So it's the primary key, can't be empty, and it auto increments, right? If you want the auto increment to start with a different value other than one, right? And a lot of people do this. For example, like if you have a big corporation, you might not want to have, start with single digit IDs. You probably want to have, like Gateway has, I think, 6 or 7 digit IDs, right? And you can tell how long somebody's been here because if their ID starts with a 0 or a couple of zeros or a bunch of zeros, they've been here forever. I'm not one of those. But you'll notice that my ID number is probably lower than your ID number. And yeah, I have one too. So sometimes sysadmins will set the auto increment to start at a certain value, and that is possible if you want to do that. And I think that's pretty interesting that that's capable. Now, when I do an insert into the persons table, so they're doing an example here, right? If you're inserting into the persons table, and let's say that table just holds first and last name and the ID, I don't need to insert the ID, right, or the value for it, because that's going to happen automatically. I just insert the names, and then the ID is added by itself because it auto increments. There's no need to send the value in. Where first and last name, I do need to send those in, otherwise they won't get set. All right, that covers actually a majority of the stuff I do want to lecture on. As you notice, and that was all the stuff that sits here. I do want to once again point out the fact that you can take a look at this alternate view of a lot of stuff. And I think that this is kind of helpful. There's a couple of things here that I'm just going to very quickly point out. I'm not going to go lecture on them, but it is also possible to create temporary tables to hold information for a moment. For whatever reason, you have to have a purpose for that. And you can also have generated columns. So in other words, you might have people enter date of birth, and then the age can be generated from that rather than you know calculating it separately. Once again, primary key, foreign key, disabling foreign key checks, a lot of the stuff we've already talked about. And then, creating indices, removing indices. And this is an interesting entry. If you're not sure what indexes you have for a table, there is a way to list them. So if you want to do that, you can look here. There are a bunch of different index types, and I'm not going to really dig really deep into this, but I just want you to be aware of it. Usually, we can index something to find faster. We can make indexes unique. We use prefixes to name them. There's also a possibility to make indexes visible or invisible, like we don't want people to mess with them or get rid of them. We can have composite indexes, which combine multiple fields, or ones that are clustered. And then we also have a couple of other things here, including cardinality and functional index, which is the result of doing a calculation, some sort of mathematical expression, usually to generate it. There are these index hints as well, and I would encourage you to read up on those, but we're not really digging deep into it. I just want to make you guys aware, and if you want to read up, you can. Now, before we go to break and switch over to maybe working on some code here, what I would like to do is talk a little bit conceptually of an example of an index and how it's used in a more practical sense. Now, I'll give you the example of going into a library. And if you guys ever did this the old school way, right? Like if you ever went to a library before they put computers in, you'd walk in and they'd have what they call a card catalog, right? And you'd walk up, and like if I wanted to find a certain book, I could look the book up, and I want you to think about this. I could look the book up by the author. So there was an index for the authors. Or I could look up the book by subject. So history or science or fiction or whatever. And then there was a separate card catalog or index for the title of the book, right? Now, every book would be listed in all three, right? So you could think of the card catalog as a library as a big database table that has columns for author, title, subject, and a bunch of other stuff. And most importantly, the Dewey Decimal number, which is the primary key index in a library. Every book has a unique one. Every book also has a unique ISBN number. But in the old days, when we would go into the library to find a book, we're like, oh, I'm not sure the name of the book, but I know it was written by so-and-so. So you go to the author index. Or, oh, I know the title, so I can just go right to the title. I don't know who wrote it. Or, you know what? I'm not sure who wrote it. I'm not sure what the title is, but the subject is motorcycle repair. So I could go to the subject catalog and look up motorcycle repair, and there might be 10 titles, and then you go find them, right? The whole point of it, ultimately, what's the point of the index at the library? To know which shelf to go to find the book, right? That's the whole point. So that's a really good example, because otherwise, if I was looking for a book on motorcycle repair at a library that might have like 4 or 5 versions of that topic, but I look at the library and there's there's 500 million books in here or something insane like that, how would you ever find it, right? And so this is the point. And although that's like a physical example, database indexes really work the same way. It's the same concept, and the point is to be able to find what you're looking for more efficiently. So let's go ahead and pause the recording here. Let's go ahead and take our break. It's let's do about a 5-minute break or so. So we'll come back at, let's call it 6:45. All right, one other little area here I wanted to talk about. I did put maybe an excess of reference materials here, but that's just to kind of keep you guys from searching. I will add videos here about exercise completion, But I also wanted to kind of point this out here as kind of like the general form for doing some of the commands that we've talked about, including links to videos that demonstrate how to do it if you really want to see somebody else demo it or read up on it at a different site. So those are there. The one command that I will be kind of using that I didn't talk about above is the explain command. And you can see the information here on it. And it says it's a statement that provides insights into how a database intends to execute a given query without actually running the query. So this is kind of interesting. All right. So we'll look at how, output for this when we're doing the exercises, but I wanted to introduce it to you before I just, pop it up during the homework completion. Basically what it shows you is the execution plan, including the table access order and which indexes, if any, it's using. And then it allows basically us, the developers, to identify potential performance bottlenecks and optimize the queries and once again, without actually running the query, it's showing you what it's going to do, right? So it's kind of looking at like a dashboard or something, telling you what's going to happen or what's happening, before it does. So all you really have to do is whatever query you're about to run, you put the explain command in front of it, and then it will give you some feedback. And like I said, we'll look at that by running it, but I just want to kind of preface it to you, like, where does this coming from? You guys don't give me any of that. So it tells you how it's going to operate before it actually does. All right. We are going to switch over to assignment mode here. So I'm going to end this video here. And hopefully it was helpful.